Welcome to Spring LIB.
All right, so we have the following chemical reaction. Let's write this out. And for part A, we're asked to calculate the volume of CO2 produced at body temperature, which is 37 Celsius. So temperature is equal to 37 plus 273, which gives us 310 Kelvin, at a pressure of 0.970 atm. And we know that the mass of glucose, which is C6H12O6. Let me do a little m. Is equal to 24.5 grams. So the volume of CO2 produced, we know that the molar mass of our glucose, calculating 6 times the molar mass of carbon plus 12 times the molar mass of hydrogen times 6 or plus 6 times the molar mass of oxygen, gives us 180.156 grams per mole. So we know that the number of moles of glucose is equal to 24.5 grams over 180 plus 156 grams per mole, which gives me 0.136 moles. Now we have the number of moles of glucose. And if we relate it to our chemical reaction, we see that 1 mole of glucose reacts with 6 moles of CO2. So we see that the number of moles of CO2 is equal to 6 times the number of moles of glucose, which is 0.136 moles, which gives me 0.816 moles. The number of CO2. Using our ideal gas equation, we can find the volume of CO2. We know that pressure times the volume of CO2 is equal to the CO2 times RT. So we know that volume of CO2 is equal to 0.816 moles times our number of liters, which is our R constant, times our temperature, all over our pressure, which gives us 21.41 liters. Okay, now for part B, we're asked to calculate the volume of oxygen you would need at 1 atmospheric pressure and 298 Kelvin to completely oxidize 50 grams of glucose. Okay, so our mass of our glucose this time is 50 grams. And our pressure, 1 atm. Our temperature is 298 Kelvin. All right, for a moles of glucose. We know our molar mass of glucose is 180.156. So the number of moles of glucose is equal to 50 grams over 180.156 grams per mole, which gives me 0.277 moles. Now, from our chemical reaction, we know the number of moles of O2 is equal to 6 times the number of moles of glucose, which is 0.277 moles. That gives us 1.662 moles. Now, using our ideal gas equation, we know the volume of O2 is equal to 1.662 moles times R times 298 Kelvin over 1 atm, which gives me 40.66 liters.